In this video, we're going to talk about the chain rule, which says that if we have a function capital F that is composed of a function within a function, so f of g of x, then its derivative, capital F prime, is going to equal to the derivative of the outer function f of g of x multiplied by the derivative of the inner function, which is g of x. So before learning about the chain rule, if we had a problem like y is equal to x squared plus 5 to the 5th power, we weren't able to take the derivative using our existing derivative rules. So now that we know how to use the chain rule, we're going to go ahead and take the derivative. So just by looking at this function, we see that we have a outer function of the 5th power, and then we have a inner function that is x squared plus 5. So what the chain rule is telling us to do is to essentially unpeel the layers by taking the derivative of the outside layer first, and then moving in toward the inside layers. So here we see on the outside we have the 5th power function. So when we take the derivative, y prime is going to equal to, we're going to use the power rule, bring the 5 down, so we get 5 times x squared plus 5 to the 4th power. So what we did is we took the derivative of the outside function, the 5th root. We're ignoring the inside for now, and we're just keeping it the same. So taking the derivative of the outside function, we get 5 to whatever was inside to the 4th power. Then looking at the inside function, the chain rule tells us that we have to take the derivative of it and then multiply it. So the derivative of x squared plus 5 is 2x. And then we can rewrite this a little bit better. We're going to say that this is equal to 10x times x squared plus 5 to the 4th power. And this is the simplified derivative. So once again, what we did is we identified the outside layer as being the 5th root function, and then the inside layer or the inside function as being x squared plus 5. And then the chain rule says that we go from outside to inside, so we took the derivative of the outside function. Using the power rule, we brought the 5 down, we minused 1 from that 5, we got a 4. We're keeping the inside function or functions alone for now, but then we multiply by the derivative of the next function, which was x squared plus 5, which was 2x, and then we rewrote it a little bit better. So let's look at another example. Let's say we're asked to find the derivative of the tangent of e to the square root of x. And once again, ddx here is a differential operator, so it's telling us that whatever is inside, to take the derivative of that. So looking at this problem, we can see that we have the outermost layer being the tangent function, the next layer being e to the form of x, and then finally the last layer being the square root of x. So using the chain rule, the derivative is going to equal to, we're going to work our way from outside to inside. We're going to essentially unpeel the layers. So the derivative of tangent is secant squared. So we get secant squared. We keep the inside the same, so we get e to the square root of x. But then we have to multiply by the next layer. And the next layer is e to a form of x. And we know that e to x is just e to the x. So we get e to the square root of x. And then finally we have one last layer, that's the square root of x. So we're going to multiply this by the derivative of the square root of x. So the derivative of the square root of x, we're going to rewrite x as being to the 1/2 power, use the power rule. So its derivative is going to be 1/2 x to the negative 1/2, which can be rewritten as 1/2 times the square root of x. So times 1/2 times the square root of x. And then we'll go ahead and rewrite this a little bit nicer. So the derivative is going to equal to secant squared of e to the square root of x times e to the square root of x divided by 2 times the square root of x. And this is the simplified derivative. Let's look at another one. So let's say we have y is equal to the square root of x squared plus 1. And we want to find the derivative y prime. So looking at this, we see that we have a square root function being the outside. And then on the inside, we have x squared plus 1. So this one has 2 layers. To make taking the derivative a little bit easier, we're going to go ahead and rewrite the function y. So without taking the derivative, we're just rewriting the function y as being x squared plus 1 to the 1/2 power. That way we can use the power rule more easily. So the derivative y prime is going to equal to, we're going to take the derivative of the outside layer first. So we get 1/2 times, we keep the inside the same, so we get x squared plus 1 to the negative 1/2 power. And then we take the derivative of the inner function and we multiply it. So multiplied by the derivative of x squared plus 1, which is 2x. And then we'll go ahead and rewrite this a little bit better. We're going to say that this is equal to 2x over 2 times the square root of x squared plus 1. And then we see that we have a common multiple of 2, so we're going to go ahead and cancel that out. Finally giving us x over the square root of x squared plus 1. And that's it. Alright, let's look at another one. So we have g of x is equal to the natural log of sine x minus cotangent x. So looking at this, the outside function is the natural log function. And then the inner function is this trig expression, sine x minus cotangent x. So the derivative g prime of x is going to equal to, first we're going to take the derivative of the natural log, and we know that the derivative of the natural log of x is 1 over x. So in this case, our x is basically all this. So the derivative of this natural log function is going to be 1 over x, or in our case, 1 over the sine of x minus the cotangent of x. And then we're going to go ahead and take the derivative of the inner function. So we're going to multiply all this by the derivative of sine x minus cotangent x. The derivative of sine x is cosine x. The derivative of negative cotangent x is going to be negative cosecant squared, which is just going to be positive cosecant squared x. And then we can imagine this as being over 1, and we'll go ahead and multiply across, giving us cosine x plus cosecant squared x divided by sine x minus cotangent x. And this is the derivative. Alright, let's look at one more, and this is going to be a challenging one. Here we're asked to find the second derivative of y is equal to x squared times e to the 5x. So when we look at this, we see that we have a function multiplied by function, indicating that we're going to use the product rule. And we also see that we have a e to the 5x, which is a function within a function. And this tells us that we're also going to be using the chain rule. So let's go ahead and first find the first derivative. So the first derivative, y prime, is going to equal to, we're going to go ahead and use the product rule. So we have first times derivative second. The derivative of e to a form of x is e to that form of x times, remember we have to use the chain rule because we have a 5x, not just an x. So the derivative of 5x is 5. So we're going to multiply this by 5. So we got first derivative second plus second e to the 5x times derivative first. The derivative of x squared is 2x. And then we'll go ahead and factor out an e to the 5x, which will give us e to the 5x times x squared times 5, so 5x squared, plus 2x. So now we'll go ahead and take the second derivative, which is what we're asked to find. So y double prime, the second derivative, is going to equal to, so once again we see that we have a function times a function. So once again we're going to be using the product rule. And then we still have that e to the 5x, which tells us that we're going to have to use the chain rule as well. So the second derivative is going to equal to first e to the 5x times derivative second. The derivative of 5x squared plus 2x is 10x plus 2 plus second 5x squared plus 2x times derivative first. So the derivative of e to the 5x is going to be e to the 5x, but because we have a 5x and not just a plain x, we're going to have to multiply it by the derivative of 5x, which is 5. Right, so this is the second derivative. So we'll go ahead and simplify it a bit. So we'll start by factoring out a e to the 5x from both terms, which will give us e to the 5x times 10x plus 2 plus 5 times 5x squared plus 2x. We'll go ahead and distribute this 5, which will give us e to the 5x times 10x plus 2 plus, we got a 5 times 5x squared, which is 25x squared, 5 times 2x, which is 10x. We'll go ahead and combine like terms. We have a 10x and a 10x. So we get e to the 5x times 25x squared plus 20x plus 2. So now we see that we have a quadratic here. So let's see if we can factor it. So we have a 25 times 2, so we have 50, and it adds up to 20. So what multiplies to 50 and adds up to 20? Well, we see that we can't actually do this. So this is a prime polynomial, it can't be factored, so that's it, we're done.